Control line flying. It's fun, exciting, and perhaps the easiest way to get started in the fascinating hobby of model aviation. The control line or U-control model is a lot less expensive than one using radio control and doesn't demand the wide open spaces needed for free flight. Therefore, control line fields can prove easier to reach for younger modelers, and the comparatively lower cost makes them attractive to everyone. But before you're ready to slow your carrier model down to a hover or fly precision aerobatics, you need to master the basics of control line model building and flying. It's easier than you might think, and by following the suggestions offered in this video, your skills will develop quickly. There's something truly special about creating a flying model from nothing more than a couple of sheets of balsa and perhaps a few sticks. To get you started in this exciting hobby, the SIG Half-A Skyray is an excellent choice. Not only is it easy to build, but its large wing area and light weight make it an excellent flyer. We chose the Half-A size as a starter model because of its low cost and economical operation. One of the little Cox engines will provide a whole lot of flying on a quart of fuel. There's no landing gear on the Skyray, and this makes it ideal for flying over the proverbial soft grass to protect it somewhat for those inevitable crashes destined to be a part of any learn-to-fly process. No expensive tools are necessary to build the Skyray, but there are a few basics you should have. No matter what model airplane you eventually build, you will need a modeling knife, and the old standby X-Acto No. 1 handle with the No. 11 blade is hard to beat. In addition, you will need a few sheets of sandpaper for shaping and smoothing balsa wood. 100 grit is coarse enough for most rough shaping, while 220 grit will work to smooth out your work. A much finer grit, such as 320 or 400, will help you get a smoother finish on your Skyray. The first step to building the Skyray, as with any kit, is to familiarize yourself with the components and the construction plans. Begin by laying out all of the components so that you can get an idea of what they look like and compare them to the plans. Notice that the Skyray is a straightforward design with few parts. It's always hard to take the extra time needed to study a set of plans when you're chomping at the bit to begin construction, but it is time well spent. As you gain experience, you will learn that most kits require certain construction steps to be followed in sequence. Failure to follow that sequence can result in having to cut away areas already assembled in order to finish constructing the model. Once you have an understanding of the construction steps and the components involved, begin construction by cutting out all parts. The wing is a good place to start. The Skyray wing is printed on a sheet of 1/8-inch medium-weight balsa. Note that the location of the bell crank, lead-outs, and other components are also printed directly on the wing for ease of positioning. Cut the wing out of the balsa sheet using a modeling knife with a new sharp blade. It's always a good idea to begin construction of a new model by using a fresh blade in your knife. A single-edged razor blade can also be used to cut out the parts, but a modeling knife is far superior in both ease of cutting and safety. Always use a straight edge whenever possible to assure that your cuts are straight and square, and always protect the part with the straight edge. That way, if the knife should slip, it will go harmlessly into the scrap and not damage the part. Use a series of passes, and never try to make the cut in one pass. Cuts that follow a curve are normally done freehand. Again, take a series of passes with your knife, making each one deeper than the previous cut. Note the direction the wood's grain runs. If your knife slips, it will naturally follow the direction of the grain. Cut in a direction that will lead the knife away from the part if it should happen to slip. You'll also find cutting to be easier in this direction. Cutting across the grain can be difficult, particularly with thicker, harder sheets of balsa. Once you get much beyond 3/16 inch thick, you will be better off using a jeweler's or jigsaw. But for all practical purposes, the Skyray wing can be cut out with an ordinary hobby knife. Once the wing has been separated from its balsa sheet, the rough edges of the cut can be dressed up with a sanding block. The other balsa components of the half-A Skyray are die-cut and easier to remove from their balsa sheet. Even the best die cutting seldom cuts all the way through the balsa, so do not try to simply punch out the parts. Instead, lightly sand the back of the sheet to help free the parts. Then use your modeling knife to finish the separation. The rudder is offset 1/4 inch. You can accomplish this by blocking up the trailing edge of the rudder with a piece of 1/4 inch thick scrap. Note, however, how this causes a gap between the rudder and the fin. Remedy this by blocking up the trailing edge of the rudder and holding it flush with the edge of your building board. Next, using a sanding block, sand the edge that will mate to the fin until the sanding block is parallel with the building board. The resulting angle will allow you to have a flush joint between the fin and the rudder. This gives you more gluing surface, making for a much stronger and neater appearing joint. Glue the rudder and fin together with medium viscosity CA adhesive. Remember, CA adhesives can bond skin instantly, so be careful. Parental guidance is strongly recommended for younger modelers if CA is used. SIG bond is a safer and dependable alternative to CA. However, if you are careful, CA is an excellent adhesive for most modeling applications. If you do manage to stick your fingers together or end up with a Skyray for a finger ornament, don't panic. CA solvents should solve the problem. Always read and follow the safety instructions printed on the label of any adhesive. Even though CA sets up quickly, it's still a good idea to give it a little extra time before working with the piece. While waiting, use your sanding block to round the leading and trailing edge of the stabilizer. Then round the leading edge of the elevator and sand its trailing edge to a slight taper. Your Skyray will fly without all of this sanding and shaping, but it will fly even better if you take the time to at least round all of the edges. This shaping gives the model a more streamlined shape and therefore less wind resistance. It also removes extra balsa, making for a lighter airplane. Although the thin wing of the half-A Skyray doesn't allow for much airfoil, every little bit helps, and this extra shaping will increase performance. Once the stab and elevator have been sanded, cut the cloth hinges into 1-inch squares. Attach them using SIG bond or other aliphatic adhesive to both the elevator and stab. Begin by pinning the pieces of cloth in position, gluing one hinge to the stab, the next to the elevator, and so forth. Use your finger to spread the glue, but be careful not to get the glue onto the hinge area. Flip both pieces over and repeat the process. This time, the hinge that was glued to the elevator goes to the stab, vice versa, until both pieces are connected. After drying, the elevator should now swing up and down smoothly. By now, the rudder assembly should be dry enough to sand. Round off all the edges except where they will attach to another part of the model. Next, the wing can be sanded to shape. It is not really necessary to sand to an airfoil shape, but it can add that extra bit of improved performance to your model. Do not round off the wing edges where it attaches to the fuselage. The fuselage is shaped also, but be sure you leave the stabilizer platform flat. Once you have all of the surfaces sanded to shape, sand them carefully with a finer grit paper such as 220. This will smooth out the balsa. It is now time to begin assembling your Skyray. Attach the wing first using a square to check alignment with the fuselage. It is also a good idea to measure the distance from the tip of the wing to the tip of the nose to assure proper alignment in this direction. Then once you are satisfied with the alignment, run medium viscosity CA along the joint. Capillary action will draw the adhesive into the crack where it will quickly set, forming a solid joint. A fillet of cement can be run along any crack that might exist between the fuselage and wing. Medium viscosity CA or SIG bond will work. Next, glue the cheek blocks to the fuselage, making sure they're flush with the nose. To obtain the strength necessary for any components holding an engine, use epoxy glue for this construction step. The firewall is then removed from the die-cut plywood sheet. Smooth it up with a sanding block and epoxy into place. When you are certain the epoxy is properly set, use a modeling knife and sandpaper to shape the nose blocks. The bell crank is attached to the wing before the stabilizer is glued to the fuselage in order to obtain the proper bell crank to control horn distance. This is necessary because of the preformed push rod. By supplying the push rod already formed, SIG eliminates the wire bending stage that many beginners find difficult. Once the bearing, control horn, and washer are cut away from the bell crank, use a modeling knife to trim the top inside edge of the bell crank pivot hole. This is necessary to let the bearing rotate freely. During control system installation, always keep in mind that a good flying model needs a smoothly operating control system. Install the bell crank by gluing the plywood bell crank mount to the top of the wing. Proper location is easy since the mount is outlined directly on the wing. Then sand the wing's surface enough to eliminate the black markings. If you use a light-colored dope to finish your model, these markings could show through unless you have done some sanding. Use the screw provided to screw the bell crank onto its mount. Don't over-tighten the screw or you will have a stiff bell crank movement. Leaving the screw too loose will result in a sloppy movement. The control horn is now attached to the elevator using the small wood screw and washer provided. Now insert one end of the push rod into the bell crank and the other into the control horn. Pin the bell crank into a neutral position. Next, slide the stabilizer forward or backward on the fuselage until the elevator is in a level or neutral position. Once this is done, pin the elevator to the fuselage and check it for alignment. Alignment is very important in model airplane construction. It can mean the difference between a good flying model and one that is a real dog. The stabilizer assembly should be parallel with the wing. Many modelers do this by simply eyeballing the alignment by holding the model at eye level and sighting down the front of the fuselage. Major discrepancies can be seen and corrected. Serious builders will go a step further by propping the model up on a flat surface and checking alignment with a ruler. The distance from tip to table should be equal on both sides, as should the distance from wingtip to stabilizer tip. This last measurement assumes you align the wing properly by measuring the distance from tip to fuselage nose. All of this might seem like a lot of extra work for your first half-A model, but developing good construction habits now will make building that Super 35 powered stunt ship a lot easier later on. When you are certain the stabilizer's alignment is satisfactory, glue it in place with CA. The rudder fin assembly is now glued onto the fuselage. Again, check alignment. Remember, the rudder is offset 1/4 inch to help keep the control lines tight when flying. With everything in place, remove the control system hardware and you are ready to paint. Before painting, smooth the entire model with number 300 grit sandpaper. Brush off the balsa dust, or better yet, use a tack rag available at most any hardware or paint store. The first coats on your new model should be clear dope. While it can be used full strength, it is much better to thin it 50-50 for better penetration and easier brushing. Even though the Skyray is not a large model, you can still use a fairly wide brush. A good 3/4 inch camel hair brush will work just fine and can be purchased either at your hobby shop or any good art or hardware store. Try to flow the dope on from a fairly full brush, working in the direction of the wood grain. Don't go back over previously doped areas, as dope dries rather quickly. and the tacky dope will pull the bristles from your brush. The unhappy result can be a model that looks like it's wearing a fur coat. After each coat of dope, flex the elevator to make sure it still works freely. Too much dope buildup in the hinge area can cause stiffness, but this flexing between coats will keep this to a minimum. Even though dope dries quickly, let the model set for at least an hour before sanding. Then, using a 300 grit paper, sand lightly following the wood grain. After sanding, it's a good idea to wipe the model once again with the tack rag to remove any dust. Then give the Skyray a second coat, following the same procedure as the first. Adding color dope to your model is where the fun begins. You can follow the picture on the kit box and paint your model with SIG Supercoat, Sky Blue, color dope, or let your imagination and artistic ability run wild. It's your model, and the choice is up to you. Whatever color you choose, thin the dope by adding 1 part thinner to 2 parts color dope. This will work well for brushing. If you have access to a spray gun, thin the dope 50-50. SIG has made it easy to trim your Skyray by supplying a set of stick-tight decals. These self-adhesive decals are easily trimmed apart using a sharp pair of scissors or knife. Cut close to the image, leaving about a 1/16 of an inch clear edge around the decal. We prefer to use the wet method of application, which allows the modeler to move the decal after it has been set on the model surface. After peeling the decal from the paper backing, soak it in a bowl of warm water for a few minutes. Using a soft brush, dip the bristles into the water and then spritz it with the Windex or Fantastic brand cleaner. Brush this solution onto the area you want to apply your decal. This soapy solution will prevent the decal from sticking to the model until you have it positioned exactly where you want it. Once it's where you want it, dab a soft cloth over the decal to absorb the excess water and begin to smooth the decal down, squeezing out any remaining air bubbles or excess soapy water from under the decal. You may also use a soft scrap of balsa to squeegee the decal. Allow the decals to dry overnight, and when completely dry, wash off any soap smears with a clean, wet rag. Once the airplane has been decorated and trimmed, attach the lead-out wires to the bell crank. Insert the brass lead-out eyelets into the lead-out guide and reassemble the control system. If you are a beginner, put the push rod into the inside hole on the bell crank and the outside hole on the control horn to limit elevator travel. When attaching the lead-outs to the bell crank, do not make the loops too small, or you may cause binding, causing a stiff control system. Make certain you put the lead-outs through the guide at the wingtip before forming loops on the end of each. Also make certain that the bell crank is in the neutral position when you form the loops, and that each loop is even with the other. If not, you will have more control in one direction than the other. Form the loops in the lead-outs using a pair of round-nose pliers. Twist the free ends tightly and smear on a bit of epoxy for extra strength. You will need a bit of weight on the outboard wing to offset the weight of the control system and lines, and 2 pennies epoxied to the underside of the wingtip will be just about right. You are now ready to mount the engine, and the integral tank supplied with the Cox 049 makes this quite easy. Just attach it to the firewall with the sheet metal screws supplied with the kit. Use 2 flat washers between the engine and the firewall on the left side to offset the engine to the right. This will help keep the lines tight while flying, and that's what we're going to do next. Before we begin flying our half-A Skyray, and since this model has the control system out in the open, let's take a look at how your actions in the center of the circle cause the plane to climb, dive, and perform aerobatics. The main components on the model are the bell crank, push rod, and the control horn. The bell crank is connected to the flying lines and ultimately the control handle by two wires called lead-outs. The bell crank is basically a mechanical device that converts the up and down movement of the control handle to up and down elevator. Note that as you pull on the up line, it pulls the rear of the bell crank toward you, causing the bell crank to exert a pushing force on the push rod. The push rod in turn pushes against the control horn, which raises the elevator into an up position. This will cause the airplane to climb. Pulling on the down line has the opposite effect, as the front of the bell crank is pulled toward the pilot, causing it to pull the push rod, which in turn pulls the control horn, causing the model to dive. Once you understand how the control system works, it's time to head out to the flying field and put this knowledge to work. Performing a few pre-flight chores before starting your engine will do a lot to ensure a fun, crash-free flight. Begin by carefully rolling your lines off the reel from the airplane's position to the center of the circle. Never uncoil the lines off the side of the reel, as you are just asking for kinked lines, and kinked lines can break, causing an accident nobody needs. Half-A models can be flown using Dacron flying lines, and many pilots do just that. Lightweight 008 or 012 wire lines, however, have the advantage of creating less drag. For this reason, serious half-A flyers usually choose wire. Be careful, though, because the lightweight wire can kink easily. Connect the lines to the model, making certain that the up line is connected to the up lead-out and the down to the down. Then, with your pit crew holding the model, walk your lines to check for twists and kinks. When you reach the handle, raise it from the ground and allow it to spin out any twists that may have occurred. While at the center of the circle, check the controls to make sure they're hooked up properly and working freely. Pull the handle back and watch for your crew to signal up. Do the same for down, and again watch for his signal. It's also a good idea to put the handle into the neutral position and have your crew check this also. Most control handles are adjustable and could have been adjusted for another model with its lead-out wires unequal in length. Once you are satisfied that everything is in order, it's time to fire up the engine and fly. The best way to learn to fly control line is with an instructor. This can be anyone with enough experience to help you start your engine and be in the circle with you in case of problems.
Got all that down? You ready to try one?
Yeah.
Okay, well, we'll just go out and I'll stay with you.
The hobby shop where you bought your model will be more than happy to recommend someone. After all, it's to their advantage to have you become an experienced model builder and pilot. Starting a model airplane engine is fairly easy, but you do need to maintain a certain amount of safety precautions. The prop can give you a nasty whack if it hits you. And while you will not be the first modeler in history to suffer this mishap, you will not enjoy it. The larger engines hit even harder, so it's important to develop good habits now. Fortunately, the Cox Black Widow engine we are using has a spring-type recoil starter. This will make things a whole lot easier. All you need do is follow the simple instructions supplied with your engine, and you should have it running in no time. But before you start the engine, check the wind direction. The model is most vulnerable to the wind during the first few seconds of your flight, and if it is blown in toward you, the lines will become slack and you will lose control. It is best to take off with the wind slightly behind the model, so that it will be climbing out with the wind helping to hold the lines tight. This will give you full control during a critical part of the flight. Once you have determined your takeoff point, have your helper hold the model securely while you start the engine. With the engine running, go to the center of the circle, pick up the handle, and check that you have it upright. When you are satisfied, signal for your helper to release the model. If your helper is inexperienced, his first tendency will be to throw the model. Don't do this. The Skyray will fly out of his hands with a gentle push needed at most. He should be careful not to point the nose in toward the center of the circle. Pointing it slightly outside will guard against this. As the plane is released, you should have the controls in neutral, and be careful not to over-control. Remember, over-control is the cause of most crashes for beginners. A good way to guard against over-control is to use the forearm to control the airplane rather than wrist movement. When you raise your arm, the airplane will climb, and when you lower it, it will dive. Wrist action will accomplish the same thing, but it will be jerkier and can easily cause you to over-control. Take it easy on your first flights and concentrate on flying smooth and level, slightly above shoulder height. Maintain this level flight until the engine quits, and then glide the model with the nose slightly down until it is just about ready to land. Then flare out with a bit of up, and you have completed your first control line flight. Don't become discouraged if your first flight was a bit ragged or even if you crash. Now is the time to begin practicing climbs and dives. Begin your first climbs with the wind at your back. Raise your arms slightly and the airplane will climb gradually. Level off by neutralizing the controls when the lines stretch upward in an angle of about 45 degrees. Fly a couple of laps at this altitude, and then with the wind again at your back, lower your forearm slightly, causing the model to dive. Level off at about shoulder height, fly a couple of laps, and repeat the procedure. Once you have mastered shallow climbs and dives, begin to increase their angle until you feel comfortable performing climbs and dives that are nearly vertical. Then for your first real maneuver, try a loop. The inside loop is accomplished by applying moderate up control from level flight and then increasing this control as the model begins to fly over on its back. The reason for this is to allow the model to gain altitude during the climb portion of the loop and then to pull out with safe room between it and the ground on the dive side. As you gain experience and confidence, you will begin to round out your loops so that you exit at the same altitude at which you entered. In the beginning, however, it is best to allow yourself a safety margin. Let's repeat the procedure. Enter the loop with the wind at your back to keep the lines tight. Begin by applying a moderate amount of up control to allow the model to gain a safe altitude before it goes over on its back. Then increase the amount of up so that it pulls out at a safe altitude. Your first loops will be anything but round, but with practice you will learn how to fly the model through the maneuver in order to achieve a nice round loop. Your half-A Skyray is capable of more maneuvers, such as outside loops and inverted flight, but these will be much more fun with the 35 version. So now that you are a competent flyer with the half-A Skyray, it's time to step up to the thrill of a full-size 35-powered control line model. Half-A is fun, but once you experience the maneuverability of a larger model and feel the firm tug it has on your lines, you will be hooked on control line flying for life. For our 35-powered ship, we have chosen our Skyray's big brother, the Skyray 35. Like all of SIG's kits, this control line model has just about everything included except engine, wheels, tank, prop, and fuel. So there will be very little you need to buy beyond the kit. For power, we have chosen the venerable Fox 35, a proven engine that has given control line flyers dependable service for over 40 years. Flying this combination will prepare you to specialize in other more advanced areas of control line flying and provide plenty of sport and fun along the way. There is more to building the Skyray 35 than the half-A version. The tools you use to build the smaller version will be used with the addition of a drill and a soldering iron. Also, this version needs more shaping, so expect to do some carving and a lot more sanding. The X-Acto 26 blade in either a number 2 or number 5 handle will be very useful, and some coarse grit sandpaper of about number 80 grit will help speed up the shaping procedure. As usual, study the plans and the construction steps before you begin gluing wood together. It will save you time in the long run. The wing construction is where the Skyray 35 is most different from its smaller counterpart, so let's begin there. The first step in any built-up wing is selecting a flat, straight working surface. Since it is necessary to hold the wing in place with pins, the surface cannot be too hard. There are several materials on the market that will work, including soft pine, homosote, and the one we chose, a section of ceiling tile. Whatever material you select, check it carefully for warps and reject it if it's not perfectly flat. The goal is to build a wing that is true and warp-free, and every degree you fall short of this goal will diminish the model's flying ability. Begin construction by taping or tacking a piece of waxed paper or saran wrap over the plans to keep the components from becoming glued to them. Next, pin the left and right spruce spar to the wing plan, butt gluing them together, reinforcing the joint with the plywood wing spar doubler. Sig Bond or other aliphatic glue is a good choice here, but always pre-glue any joint made on end grain. To do this, smear a light coat of glue on the end of each spar, let them dry, add more glue, and join together. Make certain everything is flat and in line. Add the plywood doubler, holding it tightly to the spars with small clamps or spring clothespins. The Skyray uses plywood ribs and false ribs rather than balsa. This stronger material allows the use of fewer ribs while still maintaining strength. Adding the false ribs helps keep the airfoil shape on the leading edge by not allowing the covering to sag in that area. The result is a light model without sacrificing strength. All of the plywood parts are die cut, but you still need to use a modeling knife to completely separate them from their plywood sheet. Sanding the back of the sheet will help, but eventually you will need to use your knife. Once you have freed the part from its plywood sheet, lightly sand the edges to remove any fuzz or splinters. It's difficult to push a pin through plywood, so glue a strip of 1/4-inch square balsa along the alignment tabs at the bottom of each wing rib. CA is a good adhesive for this procedure, and you might like to use a spray of accelerator to speed setting. Glue the ribs to the spar using the light ply right angles provided to keep everything lined up and square. If the ribs are warped and fail to align with the plan, just make certain they're aligned with the bottom spar and let the trailing edge fall where it may. Once you have the wing glued securely from the spar forward, you can bend the ribs into alignment before adding the trailing edge. Add the top spar and the remaining doubler. Once the spar has been glued in place, attach the leading edge. Since this is a difficult assembly to pin in place, align it a couple of ribs at a time. Hold the leading edge securely to these ribs, add thin CA, and hit it with a spray of accelerator. Next, move on down the span and repeat the procedure until the entire leading edge has been tacked into place. Additional adhesive can be added once everything is lined up. The trailing edge consists of a top and bottom piece, each made up from 2 sheets of 3/32 by 1.5 by 24-inch balsa supplied with the kit. 2 of these sheets are joined to form each. Use one of the light ply triangles to cut the scarf angle on the end of one of the sheets. Then use that sheet to lay out the angle on its joining sheet. Use a straight edge to ensure accuracy. Glue the sheets together by pinning them down on a flat surface with waxed paper under the joint. Check their alignment with a straight edge. Repeat the procedure to form the other trailing edge. Coat the bottom trailing edge of each rib with glue and add the trailing edge. Take extra pains to keep it and all the ribs in alignment. Then use pins and spring clothespins to hold it in place until thoroughly dry. Repeat the procedure with the top trailing edge, again using spring clothespins to keep it all in line. Add the half ribs by inserting them between the spars and the leading edge at an angle and then straightening them. Glue them in place with either CA or Sig Bond. Once the entire assembly is completely dry, you can remove the wing from the plans. You will need to drill an 1/8-inch hole through both the bell crank mount and the bell crank spacer. Use the plans to make certain you have located the hole properly, and be extra careful to drill the holes at an angle perpendicular to the surface of the part. A drill press makes this job easier, but an electric hand drill will suffice if you are careful. Epoxy the spacer and mount together, making certain the holes are aligned. If any epoxy creeps into the hole, you will need to re-drill after it dries. Insert the push rod into the hole provided in the bell crank and solder a number 3 washer on both sides to hold it in place. A piece of sandpaper makes a good spacer when soldering to protect the bell crank and guard against binding. Cut the 027 lead-out wire provided into 2 equal lengths and attach to the bell crank as shown on the plans. To keep both lead-outs the same length, measure 2 inches in from the end of the wire and begin your loop there. Be careful not to kink the wire or make the loop so small that it binds the bell crank. Secure the loop by wrapping evenly with the thin copper wire provided for at least ½ inch. Then fold the lead-out wire back upon itself and continue wrapping with the copper wire back toward the loop. When finished, cut off any loose ends and give the copper wire a thin coating of epoxy to keep it from unwrapping. Make sure there are no loose ends sticking out that might bind the bell crank movement. Once this is done, assemble the bell crank components to the plywood platform and epoxy the entire assembly in place. The entire model will be held to the lines by this assembly, so make sure you have strong glue joints. With the bell crank assembly installed, sheet the top of the wing with 3/32 balsa. Note that the balsa butts up to the spar rather than going over it. This procedure is an ideal place to use aliphatic glue or a slow-setting CA. Make sure you use a straight edge when trimming the balsa to fit to avoid cracks. The bottom center section is planked in the same manner, except that you must cut out a slot for the push rod. The idea here is to allow the push rod to operate freely and at the same time not make the slot so big that it allows fuel and dirt to enter the wing. Before adding the wing tips, trim the excess trailing edges and spars flush with the outboard wing rib. Then glue on the wing tips, making sure they are properly aligned and perpendicular to the ribs. Epoxy the brass eyelets to the bottom of the inboard wing and reinforce them with 3/32 scrap balsa. It is important that these eyelets are located just as they are shown on the plans, and that they are reinforced enough to stand a certain amount of stress. When the epoxy is cured, thread the lead-outs through the eyelets and form a loop on each just as you did at the bell crank. Again, make certain the loops are even and that there are no kinks. The entire wing assembly is now ready to shape and sand smooth. Begin with the leading edge, carving it close to the final shape with a number 26 blade in either a number 2 or number 5 X-Acto handle. Use the template provided to keep checking the shape as you go. When you feel you're as close to the final shape as your skill with a carving knife will allow you to go, finish shaping with sandpaper. Begin with 80 grit to remove balsa quickly, and then use 100 and 150 to finish up. Before sanding the trailing edge, let's build the fuselage. The Skyray 35 fuselage is cut oversize, but we will cut it to shape once we have the motor mounts and doublers installed. The Skyray is designed for a Fox 35 engine, so if you intend to use another power plant, be sure you adjust for the different size. If your engine is wider than the Fox, you will need to cut away enough balsa from the fuselage to increase the distance between the mounts. If it is smaller, you will need to add hardwood shims to decrease the distance. When you are certain that the distance between the hardwood motor mounts is correct for the engine you have chosen, apply epoxy to one of the fuselage doublers and then lay the fuselage in place. Be certain that the fuselage and the doubler are aligned properly. Epoxy the maple motor mounts in place and fill in with balsa as needed. Sand the motor mounts flush with the fuselage. Add the other plywood doubler. Remember when applying epoxy that there is a right and a left doubler. Clamp or weight the nose assembly and allow the epoxy to dry. Finish by sanding off any excess epoxy that is oozed out. Begin shaping the fuselage with a number 26 blade. Note that the area where the stabilizer is attached is left flat and thick enough to provide a firm platform. The nose area is carved to match the plywood doublers. The rest of the fuselage is carved to a teardrop section for lightness, streamlining, and appearance. When carving, go easy and do not try to take too big a bite. Also, be careful. X-Acto takes great pride in the sharpness of their tools, and that blade that does wonders on balsa can put a nasty slice in your finger. Smooth up the carved areas with number 80 sandpaper and then use progressively finer grits until you have a nice, smooth surface. A good choice is to follow the number 80 with 100 and then 150. Save the finer grits until after the first coat of clear dope. It's now time to assemble the wing to the fuselage, and this may take some fitting. We found that the first step was to sand the trailing edge to shape. You can only go so far here, as too much sanding will get you beyond the point where the top and bottom are glued together and create a gap. You may also find that the wing opening in the fuselage will need slightly enlarged. This is most likely just a matter of sanding it to match the plywood doubler. Go easy, as if you remove too much, you will create a gap that will need filling after the wing is attached. Your goal is to get a tight fit that is not so tight that it binds and forces the wing out of alignment. The wing can be glued in place using epoxy, CA, or SIG bond. Just remember that this must be a strong joint. There are various ways to fill the inevitable gaps between the fuselage and wing. Some modelers build up a fillet of successive coats of adhesive, and this can look quite acceptable for the type of model we are building. A more advanced approach is to use a fillet material such as SIG's epoxylite. While this will give your Skyray an excellent finish, keep in mind that as a novice flyer, you will put a lot of wear and tear on these first models, and it might be better not to get too particular until you have gained flying experience. The stabilizer and elevator should have all edges sanded round before they are attached. Then lay the stabilizer over the plans and mark the locations for the SIG easy hinges. With an X-Acto knife and a number 11 blade, cut a slot in the elevator about ½ inch deep and slightly larger than the width of the hinges at each hinge location. These slots should be at the center of the thickness of the elevator, and you must be careful to keep the blade parallel to the surface of the elevator. Angling the knife will cause it to cut through the surface, making an ugly gash in your elevator. A good way to ensure accuracy is to build a simple jig for cutting hinge notches. Since the elevator and stabilizer are both 1/8 of an inch thick, you can use a piece of 1/16 inch by 1/4 inch hard balsa to guide your blade. Sand the balsa just a bit thinner to allow for the blade's thickness. Lay the part on a flat surface, pulling the edge where you want the hinge slot tight against the balsa guide. Then, with the blade flat on the guide, you should be able to cut an accurate slot. When cutting the slot, it's a good idea to insert the blade from both sides, working toward the middle. Insert the hinges in the slots cut in the stabilizer, and then use this to mark the slot locations on the elevator. Use the same method used on the stabilizer to cut the elevator slots. Now slide the elevator onto the hinges and apply a bit of CA where the hinges meet both the elevator and stabilizer. You should flex the assembly after the CA sets to make certain you have not glued the parts together. Drill out the bottom hole of the control horn to accept the 3/32 inch push rod. Insert the push rod and solder a number 3 washer on each side of the control horn to keep it in place. Install the control horn on the elevator, making certain you did not bind the push rod from side to side. With the bell crank in neutral, slide the stabilizer assembly fore and aft along the fuselage until the elevator is in neutral. Pin the assembly in place and carefully check alignment. Once you are certain everything is perfectly aligned with both the fuselage and wing, fasten the assembly in place with CA. The rudder is attached to the fin with a 1/4 inch offset to the right as viewed from the rear. To make a gap-free joint, prop the rudder up 1/4 of an inch on a flat surface with a perpendicular edge, just as you did with the half-A Skyray. Use a sanding block to angle the edge of the rudder to match the edge of the work surface. Glue the rudder to the fin, Round all the edges of the fin assembly, attach to the fuselage, and check for proper alignment. The basic assembly of your Skyray 35 is now completed. The model is now ready for clear dope, and we have found that SIG light coat is hard to beat. Thin only as much as necessary for the brush to flow freely. It will help keep the bristles from pulling out if you don't try to brush the dope out too much. Just let it flow smoothly with a minimum of brush strokes. Pay particular attention to the top of the ribs and anywhere that the covering material will be attached to the wing. Apply 3 coats at this time. Allow each coat to dry thoroughly, then sand lightly between coats with number 150 or 220 sandpaper. The object is to obtain a smooth finish beneath the covering material, but while you are at it, you may as well get a couple of extra coats on the rest of the Skyray. After 3 coats of clear, you should have a good surface for applying the covering. There are many types of covering that are suitable, such as silk span, silk, and monocoat, but we will be using SIG coverall for this model. We will attach it with Stix-It and use heat to both adhere it to the structure and to shrink it drum tight. Begin by applying a coat of Stix-It to the wing's leading edge, trailing edge, root, and tip. Do the top and bottom panels on both sides. Allow the Stix-It to dry and then cut a piece of coverall slightly larger than one wing panel. Make sure that the grain of the covering material runs span-wise, or you will get sags in your covering job. To attach the coverall, you can use an ordinary household iron, but if you can buy or borrow a regular covering iron, the task will be somewhat easier. Lay the material out on the bottom of one wing panel, as it's best to cover the bottom of a wing first. Then tack it on all 4 corners while stretching it enough to take out most of the wrinkles. You do not need to stretch the material drum taut at this point. Coverall has excellent shrinking qualities, so it is more important to keep the wrinkles out so that when you shrink it, you will have a nice, smooth covering job. After tacking the corners, iron the covering down to the rest of the wing. Do the root first, then work your way toward the tip, smoothing out wrinkles and pulling the covering taut as you go. One covering problem that did surface with the Skyray was caused by the thin plywood wing tips. The 1/8-inch thick tips leave very little area for the covering to adhere to, particularly when both the top and bottom covering must adhere to the same surface. We solved the problem by first attaching the bottom tip covering, then recoating it with Stix-It and fastening the top covering to that. The top covering should be wrapped around the leading and trailing edge so that the seam between it and the bottom covering is on the bottom of the wing. Trim the excess covering with a single-edge razor blade. When trimming, try to obtain as neat a seam between the bottom and top covering as possible. With the top and bottom wing panels covered, the next step is to heat shrink the covering to remove all wrinkles. Be a little cautious here, as coverall seems to shrink forever if you keep applying heat. Just shrink it taut enough to look good and obtain a nice, smooth airfoil. You can shrink this material with your covering iron, a household iron, or a heat gun. If you can shrink the bottom and top panels evenly, you will help avoid warps. This is a good time to attach the single landing gear, as it gives you a handle of sorts while doping. Use the Skyray plan to locate the point where the landing gear enters the fuselage and drill an 1/8-inch hole. Insert the landing gear, sweeping it back as shown on the plans, and use the landing gear strap to drill 2 1/8-inch holes through the fuselage. Attach the landing gear strap using the 440 by 1-inch bolts and blind nuts supplied. Apply at least 3 coats of clear dope to the entire model to seal the coverall and give the wood a smooth, glossy surface. The model should be sanded lightly between coats, but take extra care when sanding the fabric covering. If you sand too hard or long, especially where there is a rib or other structure beneath the covering, you could sand through. After sanding, always wipe the model down with a tack rag before applying the next coat. In reality, your Skyray can be flown as soon as you have applied enough clear dope to seal the fabric and wood. If you are not too certain of your flying skills, take your Skyray out to the field and make your mistakes before you go the extra step to produce a thoroughly finished model. Once your Skyray 35 has been painted to your satisfaction, it's time to install the engine. We chose the venerable Fox 35 Stunt for its reliability. Installation is straightforward. Just mark the location of the mounting holes using the engine as a guide, drill the holes, and attach the engine with the 440 bolts and blind nuts supplied with the kit. A washer between the front of the engine mounting lug and the motor mount will add a bit of engine offset, so the thrust will help keep your lines tight during flight. The fuel tank is installed according to the location shown on the plans, making certain that the fuel pickup line is lined up with the engine intake. Use the J-screws provided and rubber bands to hold the tank in place. A piece of RC foam rubber between the tank and fuselage will help cut down on vibration in the tank. Attaching the wheel completes the Skyray 35 construction, and it's time to fly. If you enjoyed flying your half-A Skyray, you're going to love the Skyray 35. It's an ideal intermediate step into a wide range of exciting control line events. The Fox 35-powered Skyray flies using the same principles as the half-A version, in that the controls work the same. However, the similarity ends when your 35 roars to life and you begin that first flight. The heavier, more powerful aircraft handles much more smoothly than the smaller models, and that will enable you to improve your flying skills considerably. Follow the engine's instruction manual as to starting procedure and proper fuel. For most control line engines, you will need to add additional lubricant to the RC fuel available at many hobby shops. Starting the larger engines demands caution. If you prop the engine by hand, you should wear a glove on the propping hand to protect you from sharp propellers. For your first flights, keep the engine setting a little on the rich side. This is especially true with a new engine that is not totally broken in. The Skyray 35's takeoff is different than the half-A because it has a landing gear and can be taken off from the ground. Your helper should release the model without pushing it. Hold the controls in neutral to allow it to gain speed and then add just a slight amount of up elevator. Once the model has climbed to about shoulder high, level off and fly a few laps to get acquainted. As soon as you feel comfortable with the larger, more powerful aircraft, go ahead and review the maneuvers you practiced with the smaller Skyray. They are the climb, the dive, the loop. When the Skyray is gliding, it will have less pull on the lines, so you may find that you will need to backpedal a bit to maintain control. Keep the nose down to hold your flying speed until the airplane is close to the ground, and then level off to allow it to slow down. If it begins to stall, drop the nose, but be sure to flare out just before touchdown. Only experience will teach you how fast to approach a landing, and you will make a lot of lousy landings while learning. Fortunately, you'll have a lot of fun at the same time. We promised to try some new maneuvers with the Skyray 35, so let's get back in the air and give them a try. When in inverted flight, your controls are reversed, and this can cause some confusion to the beginner. One way to help remember that down is up and up is down is to hold the control handle with your palm up once you enter inverted flight. This makes it much easier to use the proper control than holding the handle normally and trying to remember which way to move the handle to make the model climb while inverted. It's best to enter inverted flight at a higher than normal altitude, and this means that performing half a loop is an excellent way to get there. Just neutralize the controls as the model becomes inverted and level at the top of the loop, and you will be flying inverted. Rather than trying to complete a lap of inverted flight, it is best to add down elevator shortly after achieving an inverted attitude so that the model climbs up and over to an upright flying attitude. Each time you practice this, stretch out the time spent inverted until you can complete a lap or more. The outside loop can be entered from inverted flight and is performed just like the inside loop, except that down control is used instead of up. To perform this maneuver, fly inverted and level at a fairly low altitude. Then apply down control. The model will climb from an inverted position and then fly over the top of the loop. At this point, apply more down so that the model will complete the bottom half of the loop at a safe altitude. As you gain confidence, use less down at the top so that the model will recover closer to the ground, making the loop more round. The more you practice, the more perfect your loops, both inside and outside, will look. Our final maneuver for this video is the figure 8, which is nothing more than stretched out inside and outside loops flown back to back. Begin by applying up control just as if you are going to perform an inside loop. The model flies over the top of the loop and starts down. Begin to apply down control until you perform an outside loop. However, instead of allowing the model to go all the way through the outside loop into inverted flight, use up control to return it to the same point where you began the inside loop. Level off, and you have completed a figure 8. The figure 8 maneuver completes your basic control line training. It's up to you now to practice until you can perform each maneuver smoothly and with confidence. As your skill increases, you may choose to try other forms of control line flying, such as Navy carrier or precision aerobatics. There are contests held each year for these events. But whether you intend to fly strictly for fun or plan to enter the exciting world of competition, control line flying will provide you many hours of hands-on model aviation. It's a hobby that lasts a lifetime.